Okay, I wanted to make a recording of all of the problems on the back because there were a couple classes that did not get a chance to see these problems being worked out in completion, or even if you did see it, I was maybe moving a little too fast. So I wanted to make a quick video of numbers 14 through 19, and hopefully if you watch this, you'll be ready for tomorrow's quiz. So here we go. Remember, with number 14, my first initial thought is I got to get this radical and everything under that radical isolated. So in order to get that done, I've got to take that plus 4 and I got to move it out. And I do that by subtracting 4. So the square root of 5x minus 1 stays underneath that radical on the left side. But on the right side, 11 minus 4 is 7. So once I've gotten that isolated, my next job is going to be to get rid of that radical. So since the root is 2, so right, square root of 5x minus 1, I want to square both sides in order to get rid of that radical. So on the left side, the radical and that square, they cancel. So 5x minus 1 drops straight down. And then 7 squared equals 49. Okay? So from here, it's just solving a pretty simple problem. We're going to add 1. And then I'm going to divide by 5. So x equals 10. Now again, and I'm going to do this over here to the right. But remember, you can just type this into your calculator. I would encourage you just to type in the square root of 5 times 10 minus 1 under the radical plus 4 into your calculator and see if it equals 11. So 5 times 10 is 50 minus 1 is 49. The square root of 49 is 7. 7 plus 4 does in fact equal 11. So since 11 does equal 11, then that means my answer is 10. Okay, x equals 10. It is not extraneous. So that's number 14. Pause it if you need to. I'm going to move on though to number 15. I would probably recommend you to really focus on this one because I would say the likelihood of one being on the quiz very similar to this tomorrow is a good possibility. There's my radical. I got to get that radical alone. So I know that I need to move this 1 and this negative 2. The 1's further away, so I got to move it first. And since it's a separate term, we can move it by doing the opposite. Since it's positive, we're going to subtract 1. So we're left with negative 2 times the square root of m plus 12. And that equals 5 minus 1, which is 4. And then I'm going to get rid of that negative 2. Again, since it's right next to that square root, what it means is it's multiplying. So we're going to divide by negative 2. These will cancel. So the square root of m plus 12 equals negative 2. Now, from here, I've got this radical isolated, so we can get rid of it now by squaring both sides. So on the right side, remember, you're squaring negative 2. So you need to be careful, make sure you put it in parentheses, because negative 2 is getting squared. That means negative 2 has to multiply by negative 2, which you know is going to become a positive 4. And then, of course, on the left side, you're left with simply m plus 12. So from here, you subtract 12. So 4 minus 12 is negative 8. Now, again, if I go up here and I plug that in, if I go 1 minus 2 times the square root of negative 8 plus 12 in my calculator, we're going to see if that equals 5. Well, negative 8 plus 12 is 4. The square root of 4 is 2. 2 times 2 is 4. So that's going to be 1 minus 4, which is negative 3. Does negative 3 equal 5? No. So this is what we call extraneous. It's a solution that doesn't work. So we call it extraneous. All right, number 16. Number 16 is the exact same as far as the process goes. Remember, it's just written in what we call rational exponent form. See, it's raised to the 1/3 power. That really just means the cube root of, right? we've talked about that. The denominator is the root, cube root of. So we said the other day, to get rid of these rational exponents, we're going to raise them to the power of the reciprocal. Well, the reciprocal of 1/3 is 3. So we're going to raise it to the third power on both sides. So when I do that, these are just going to cancel out, and I'm bringing down 9a plus 45. But on the right side, 3 to the third power, 3 times 3 times 3 is 27. So 9a plus 45 equals 27. So once you get to this, it's just a very simple solving equation. You subtract 45. 27 minus 45 is negative 18. Then to get a alone, you divide by 9. So negative 18 divided by 9 is negative 2. So a equals negative 2. Again, I would encourage you guys to go to your calculator and go like this. 9 times negative 2 plus 45 raised to the 1/3 and see if it equals 3. Well, that's negative 18 plus 45, which is 27. 27 to the 1/3 power, or the cube root of 27, does in fact equal 3. So since 3 equals 3, that is my answer. All right, moving on to number 17. Once again, this is probably the last of the just really easy problems, because you have square roots on both sides. So when you square these to get rid of that, it's going to leave you with just 3n minus 27 equals 43 minus 2n. So there's really no problem with this besides just getting your like terms together and solving. You don't have to factor. It's real simple. So remember, I like to look at these two, the 3n and the negative 2n, and just determine which one's smaller. Well, it's the negative 2n, so I'm going to add that 2n to move it to the 3n. 3n plus 2n is 5n minus 27 equals 43. So now I'm just going to process getting n alone. I'm going to add 27. 43 plus 27 is 70. And then I'm going to divide by 5, so n equals 14. If I go back and I plug these in, I'm going to go square root of 3 times 14 minus 27 equals the square root of 43 minus 2 times 14. And what you end up getting here is, 3 times 14 is 42, minus 27 is 15, and then 2 times 14 is 28. 43 minus 20 is also 15. So this is going to be the square root of 15 equals the square root of 15. If you use your calculator, though, you're probably going to get like 3.9-ish equals 3.9-ish. So sure enough, those are equal, so n equals 14. Okay, and then we get to the problems where we dealt with Monday when we came back to school and went over a couple of these examples, and then also you had homework that we went over today in class that do these type of problems. So here you have 18 plus 7k being raised to the 1/2. So again, we're going to raise this, since it's in rational exponent form, we're going to raise it to the reciprocal power, which is squared, right? 1/2. The reciprocal is 2 over 1, or 2. So that's going to allow these to cancel, and you're going to be left with just 18 plus 7k, and that's going to equal the k squared over here. See, this is why this problem is a little harder. You can't just solve for k like we've done in those last 4 problems. You got to load up a side, and then you got to factor it. So I'm going to subtract that 7k over there, and I'm going to subtract that 18 over there. That way I can just load up one side, and that will give me the opportunity to factor it. We factor trinomials into 2 binomials. So that's k times k, right? And then here's where you have to think a little bit more. What multiplies to get 18? You got 1 times 18, you got 2 times 9, you got 3 times 6. So you got 3 different possibilities, right? So how do I pick? Well, it all starts right here with this minus sign. What that's telling me is to multiply to get a negative, one of these have to be positive and one of them has to be negative. So they're working together. They're working against each other to give me the 7 right here. So I look at all these examples. Which ones will go against each other to get 7? 1 and 18 give me 17. 3 and 6 give me 3. It has to be 2 and 9. The gap between 2 and 9 is 7. So the last thing I do is I recognize that this is a minus 7. Negative wins when you combine these two. So therefore, negative has to go with the bigger of those two factors. So negative has to go with the 9. And 2 has to go with the plus. So my two factors that I'm setting equal to 0 are k plus 2 and k minus 9. And then the solving from here is really simple. With this one, we're going to subtract 2. With this one, we're going to add 9. So our solutions are negative 2 and positive 9. Now again, if I go back up to my original problem here and I plug those in, so over here, you're going to do, let me change the color here to red. We're going to do 18 plus 7 times negative 2 raised to the 1/2. And we're going to see if that equals k, which again is negative 2 here. Well, that's 18 minus 14, 4. 4 to the 1/2 power, or the square root of 4, is 2. Does 2 equal negative 2? See, 2 does not equal negative 2. So this is extraneous. All right, so let's do the same thing here. We're going to go 18 plus 7 times 9 raised to the 1/2, and we're going to check to see if it equals k, which is 9. So 7 times 9 is 63. 18 plus 63 is 81. 81 to the 1/2 power, or the square root of 81, is 9. Does 9 equal 9? Absolutely. So k equals 9 is good. And there you have it. That's how you do number 18. Hopefully you'll think that's very simple. I'm going to erase this just to move over, just to get that out of the way. Let me erase all this stuff that we just did over here, and let's focus on the last one. Now this one has one little trick to it. Is this radical isolated? Definitely not. We got to add that 4 to move it over. So we're left with 6x, the square root of 6x plus 19 equals x plus 4. So now when I square this side and I square this side, I'm squaring the entire thing x plus 4. So on the left side, those cancel, and we're left with 6x plus 19. But on the right side, we're dealing with x plus 4 times x plus 4, which we did yesterday, a couple of problems. So 6x plus 19 equals x times x, x squared, x times positive 4, positive 4x, another positive 4 times x, positive 4x, and then finally positive 4 times positive 4, positive 16. Now if I was there showing you, I would erase those two, but I'm just going to rewrite it. So we have 6x plus 19 equals x squared. Those are like terms, so plus 8x plus 16. I'm going to move all this stuff on the left side over. So I'm going to subtract 6x from the 8x because they're like terms. I'm going to subtract the 19 from the 16 because they're like terms. And that's going to help me load everything on one side. So I'm left with x squared. 8x minus 6x is positive 2x. And 16 minus 19 is negative 3. So here we go. We're going to factor this into two binomials. So the easy stuff, x times x. What are some things that multiply to get 3? Well, really, you only have 1 times 3. That's it. So it has to be those two numbers. So let's just make sure we understand how. Remember, to multiply to get a negative, one of these has to be positive and one of them have to be negative. They're working against each other to get me 2. Does 1 and 3 work against each other to give me a 2? Absolutely. So last thing, that positive wins. So you have to give positive to the bigger value, and that is the 3. So my factors are, sorry everyone in our room, are x plus 3 and x minus 1. So my solutions are x equals -3 and x equals +1. So I'm going to go plug those in real quick. Sorry again that I'm out of room. I plug it up to the original problem. And I'm just going to do this over here to the side. So you're going to go type this in probably to your calculator. The square root of 6 times -3 plus 19, and then outside of that -4. And you're going to see if that equals x, which again is -3. What's -18 plus 19? That's 1. Square root of 1 is 1. 1 minus 4 is -3. Does -3 equal -3? Absolutely it does. So x does equal -3. And then lastly, let's do the 1. So it's the square root of 6 times 1 plus 19. And then outside of that -4 equals x, which is 1 this time. Well, 6 times 1 is 6, plus 19 is 25. Square root of 25 is 5, and 5 minus 4 is, in fact, 1. So 1 does equal 1. So both of these are correct answers. So there you have it, guys. This is how you solve radical equations. We've been dealing with it since last Thursday. Hopefully, with the 3 problems that we'll have on the review, or on the quiz, you'll be in good shape to do those. All right? Hope you understand everything. If you have any questions, you need to probably email me pretty soon because we're going to take that quiz right when we come into class tomorrow. Have a good night.